All right, so the idea of modeling is also called regression. Is a major component of the AP Calculus curriculum and will be revisited throughout the course. These topics will utilize graphing calculators heavily and often include context. So those of you guys that are my juniors that are thinking about taking stats also next year, this will come up in AP Stats, is using your calculator to model. If you guys are gonna take stats in college, they obviously won't give you guys a calculator like this, but when you guys take stats, I highly recommend one of these calculators for stats. In Unit 1, we worked with polynomial functions and for rational functions. So to build the regression model, this walks you guys how to do it. So you're gonna be given a table, right? I'm gonna show you guys how to do it, but if you guys can just go ahead and try it, hit stat. It's underneath the delete key. And then you guys should see this menu right here. It says edit, calc, tests, and so on, okay? What you're gonna do is you're gonna hit edit, and then you're gonna see this menu right here, okay? What this means is L1 stands for like list one. What's up? Okay, try now. L1 stands for list one, L2 stands for list two, and so on. So what you're gonna be doing is if I give you guys a table and L1, you're just gonna start typing in a number, hit enter, 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 and to enter all the numbers, okay? So, and then list two and so on. Once you're done with that, then what you could do is you can tell your calculator to create a model. So based off the situation, you guys are gonna learn like, should I make a linear model? Should I make a quadratic model? Should I make a cubic model? This is quartic, so that's like 4th degree polynomial. 1 variable stats, 2 variable stats. If you guys take statistics, do you guys remember finding like mean, median, mode, things like that in Math 1? If you guys typed in a list of numbers, your calculator can find all that for you right away. Mean, median, mode. I'm teaching stats right now. I haven't taught them that the calculator can do that on purpose, but it can, okay? And then based off that, you can tell it how to make the function. So let's go ahead and practice one. So let's look at example 1. Okay, so this is my first time teaching this, so let me explain this problem, and then I'll explain to you guys what I think is gonna happen most of the time, okay? So let's just get through the problem, and then I'll tell you guys what I'm talking about. So let's read it. It says the age and weeks and weight in kilograms of 5 randomly selected babies from a particular pediatrician's office are listed in the table above, okay? So a couple things you guys wanna pay attention to is the table itself says that Y is a predicted weight of the baby in kilograms, and X represents how many weeks old the baby is. Okay. Now, in this problem, it says we're going to use the linear regression. Y is equal to A plus BX. This is an option in your calculator, but we need to put the data in first before we do anything else. Okay, so I want you guys to stay with me and walk with me on how to do this, okay? So this right here is your X values. This right here is your Y values. So what you're going to do is you're going to go to stat, edit, type these numbers into L1, type these numbers into L2, and then just wait. So that way I can show you guys what to do next. Okay? So you guys have it in front of you. I'm going to do it on my calculator too. So 4, 5, 6, 8, 12, and then 4.2, 4.4, 4.8, 5.1, 5.7. Okay, is everybody good there? Talk to me, guys. No, I had something. Everyone good? Okay. Once you have your data in there, you good? Okay. What?
It died.
Oh, it died?
Yeah. Thank you.
You're welcome. Okay. So now we need to calculate the linear regression. So to do that, you're going to hit stat again. And then the second menu says calc. Now, this is important because notice that there's two linear regression models, okay? This is more like a statistics type question. I'm not an expert in stats, but there's a difference between these two. I'm gonna learn the difference between these two, that way I can explain it to you, but right now I can't. So the problem wants us to do A plus BX. So you're gonna scroll down to A plus BX and hit enter. Now notice that it says your X's are L1. Is that true? From our table, is that what we want? Yes. And our Y's are L2. Is that true? Yes. Make sure that it's correct, okay? Now, before you do anything else, we want to store this equation. This is very important that you do this because otherwise you're gonna be causing yourself a lot of work. So, do you guys remember when we did like the average rate of change stuff earlier in the year and I showed you guys can retrieve Y1? Do you guys remember that? So if you guys don't remember that, you're gonna go to vars, yvars, okay, yvars, and hit function, so hit enter, and then just hit Y1. What this means is it's gonna make our function for us, and then whatever our function is, it's gonna throw it into Y1. Okay, so that way you don't have to copy it again. And then once you do that, you're just gonna go down to calculate and hit enter. And that's my function. Okay, so we need to be able to read this carefully. The equation is supposed to be like y equals mx plus b, but in this case, it's like something plus something x. So to write it down, you're gonna write y equals 3.545 plus 0.185x. That's your function. So going back to our notes. So this was L1. This is L2. Notice that I'm highlighting everything in the same colors, so that way it matches. Okay. We chose the linear regression A plus BX because that's what it told us to do. We stored it into Y1. I need to fix my calculator because it gives us the R values. This is important. Did your calculator give you guys R values? No? I need to see how to do that. I forget how to make it so it does that. So Y is equal to A plus BX. So A was 3.45 and B was 0.185. So it's going to be 3.545 plus 0.185x. So this is our model. Before I move forward, is everybody okay? Yeah? It's not too bad yet, right? Getting the equation part's not that bad. The next part is kind of more difficult because you have to be able to understand what the problem's saying. So it says, using your model from part A, so using the answer we just got, what is the predicted weight in kilograms of a baby that is 10 weeks old? So using our model, remember X is weeks, Y is the weight. So what is the predicted weight? So what is Y when X is 10? All right, so there's a couple ways you could do it. We have our equation here, right? But a lot of times what you're gonna do is you're gonna have a crazy number for A and a crazy number for B. So what we'll do is when we actually write our answer on paper, we'll round it to 3 places. But you want the exact answer, so do you guys remember we stored this function into y1? So if I wanna know what is y when x is 10, you're basically going to just do y1 of 10. So to do that, I just picked up this, like you guys are gonna be able to see it. To do that, you're gonna go just second quit, and then retrieve y1. So you're gonna do vars, y vars, hit y1, and then you're just gonna plug in 10. And that's your answer. For unit 1, right? The limits test?
Yeah.
Okay. And we get 5.395. Okay, questions on that? Okay, what is part C saying? Anybody? Is part C asking us to do the same thing? No? So what's different this time? What do we know now instead? X or Y? X? We know. Do we know Y or do we know X? It's the blank one's printing for you right now. We know Y this time, right? So now we know Y. The weight is 5.3. What is the age? So what is X when Y is 5.3? So now what we can do is we know this is our function, right? So what we can do is just plug in Y in right there and then solve for X. So 5.3 is equal to 3.545 plus 0.185x. Okay, you guys are pre-calculus students. This is a really easy equation to solve. You guys have a calculator. So the only scary part is the decimals, right? But you guys have a calculator. So do you guys agree? I just have to subtract this to both sides and then just divide by that number. So x is going to be whatever 5.3 minus 3.545 divided by 0.185, whatever that is. What is that, guys? Yes, and X stands for weeks. Okay, questions? Are we okay? Yeah? Okay. All right. So like I said, this is not the only time we're going to do this. I kind of want to put you guys through like a regression like boot camp, like 1 week, like before the AP tests, like that April time period where we have time to review, where we'll just do a bunch of different problems and you guys will practice making the equations, answering questions, how to know what type it is, all that stuff. Because if you guys can do that, then you guys should do really good on the AP tests, okay? But, so this is the first time we've seen this, but these are basically the things you guys want to pay attention to. So if I give you guys a table or give you guys a situation, how do I know what type of model it is? So a linear model, you guys are in pre-calc. Think about lines. Lines look something like that, right? Or the slope is constant. The slope here everywhere is like 1/4 or -5 or whatever, right? It's a constant rate of change. So linear models roughly have constant rate of changes. Quadratic models. Think about a parabola. A parabola either has a max or a min, right? So what will happen is your table is going to have values that go up, 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 and then start to go down, 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 down. Or they go down, 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 and then start to go up, 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 up. Okay? So then quadratic models have roughly linear rates of change, or they're roughly symmetric with a single maximum or minimum, or it's context involving area. Length times width, or a circle, pi r squared. Okay, cubic models. Cubic models are usually contexts that involve volume. Okay, are we okay? Okay. And hopefully nobody did this. Don't clear y1. Leave your function in y1. Okay, because we're going to need it here in a little bit. All right. So for example 2, it says, for each of the following situations, determine whether a linear, quadratic, or cubic model would be most appropriate. So for part A, it says, balloons are being filled with water in preparation for an epic water balloon battle. Each water balloon is roughly spherical. The radius of each water balloon is measured relative to the amount of water it holds. Okay, not a trick question. When you fill up a water balloon, Is it something that's flat, or is it like 3D? It's 3D, okay? So if you guys were to calculate anything to do with that balloon, that would be volume, because volume is 3D, okay? So what do we know about anything with volume according to our notes? What's the model that would be most appropriate to use? Cubic, okay? So from our notes, volume would be a cubic model. That's all it's asking you to do. We don't have any data to actually calculate the equation. It's just getting you to understand which model you would use. Okay, this is a major throwback because these were like something we used to have when I was a little kid all the time. The little pizzas, Totino's pizzas. So when I saw this example, I was like, oh, I haven't had those in years. Totino's pizzas are on sale at the local grocery store. The price of one pizza varies between $1.99 and $2.19, depending on the variety. The total number of Totino's pizzas are counted relative to the total price of the purchase. Okay. So here is a hint. The price of one pizza varies between $1.99 and $2.19. So those are pretty close, right? So what's going to happen to your total when you guys are checking out the grocery store, the more pizzas that you buy? You're going to owe more money or less money? More money. So the more pizzas that you guys buy, you guys agree the total is going to go up, right? So what type of model is this? Linear. Okay, so this is a linear model. And the way that you know that is it's roughly a constant rate of change. A sprinkler is placed in a yard to water the grass. The sprinkler rotates in a circular pattern and waters all the grass between the sprinkler head and the furthest distance it reaches. The radius of the circular path is measured relative to the area watered by the sprinkler. So based off what we've talked about, what is the most important word in this whole problem? Well, part A also had radius. Area. Because what do we know about area in terms of models from our notes? What's the best model? Quadratic. Quadratic because think about it, guys. It's circular, okay? But let's pretend like our lawn for a second is rectangular, okay? Do you guys agree this would be like X, maybe like Y? Whenever you multiply two things that are two-dimensional, you're going to get like X times Y. Or if this is like X plus 1 and this was like X plus 2 and multiply it out, do you guys agree you get X squared plus something else? That's quadratic. Okay, that's why it's quadratic. I met this lady at my Avid conference that like related everything with parabolas to area, and she was like so smart. She actually hooked it up with a bunch of calculus stuff, so she's listening to my YouTube. Shout out to her because she definitely helped me out a lot. But this is quadratic. The way that you know that is because it's area. All right. New modeling question. So it says, the table above provides data for 8 ordered pairs. Which function type best models the data in the table? Linear, quadratic, or cubic? Explain your answer using characteristics from the data in the table. Okay. So this is how you're going to answer this question. What's happening with the x's as I go this way? Which direction are they moving? They're getting bigger, right? Look at the y's. It's getting bigger, 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 but then what happens? Starting to go down. So what I want you guys to think about is the graph is going up to 18, and then after 18, you guys agree it's starting to go down. What does that look like? It's quadratic, okay? Because this would be a what? A maximum, okay? Does that make sense? So because the table is starting to increase the y values and then it starts to go down, that indicates that it's quadratic. And if you look, our notes say that it's roughly symmetric. So around 18, do you guys see how like these numbers around it are pretty close? Okay, and then these numbers are, wait, no, maybe not, but it's roughly symmetric. So this is quadratic. And the way that you guys say that, y, roughly symmetric with a maximum. All right, now it says to write the equation. So the first thing you're going to do is you're going to enter the data into your table. Okay, so there's a fast way to do this. So I don't know why I keep doing this. I keep grabbing my calculator like you guys are going to see my calculator in my hand. Okay, so when you go back to stat, edit, your data is still there from last time. One thing you guys could do is you guys can just hit delete, 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 or you can just go up to the top where it says L2 and just hit delete. Oh wait, no, don't do that. Just kidding. Because then it deletes all of, dang it. Maybe not do that. Okay, my bad. I'm gonna reset my calculator. Don't do that. Second, reset. Dang it. All right, another thing you could do, my bad, is go to stat, clear list. And then to clear a list, what you could do then is go to second list. And do you guys see how it has the names of your lists? So if I want to clear L1, I would just hit enter and it would clear all of list 1. Okay? That's helpful if sometimes you guys have like 12 entries and you don't want to hit delete, 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 delete. Okay? All right, so let's go back to entering this in now. All right, so L1. So I'm going to hit in the X's. So 0, 0.4, 0.9, 1.2, 1.7, 2.2, 2.9, 3.4. Okay, we good? Oops. Okay, so this is what we're gonna do now. What type of model is this supposed to be? Quadratic. So to calculate the model, you're gonna do the same thing. You're gonna hit stat again. Scroll over to calc. And then you're gonna scroll down to quadratic regression. Okay. So then what I want you guys to do is, did you guys clear your calculator like I told you guys to? If you guys did, it's okay. What I want you guys to do is, our first example we're gonna use again here in a second. So can you guys store this into Y2? So go to vars, yvars, store it in Y2. And then hit calculate. Okay. Raise your hand if you did not get that.
Or just alpha tricks.
You know how to do it. So okay. So in this case, we're not using this function to calculate anything, but this is why it would be important to you guys to store it, because then I could do the thing where I recall the function and plug things in. You guys follow me? Like we did in the first problem. It's because you guys see how these numbers are a little bit crazier. But when you guys are writing your answer down in AP pre-calculus, we round to 3 places when you're actually writing an answer down. So all you're gonna do is you're gonna take each of these coefficients and just round them to 3 places. So you write your function as ax squared plus bx plus c. So y equals, if I round that a value to 3 places, it'd be negative 4.883 x squared plus 15.958x plus 4.996. Okay, questions? We're good? Okay.
Reset the after you put that on the LCD.
Second memory 712. All right, last thing. We're gonna see this again in Unit 2, but I'm gonna introduce it to you guys now. So it says, when we use a model to predict values, we expect our model to produce values that are reasonably close to the actual value. But our models are not expected to be exact. And the reason why is because this is the same example from example 1, right guys? So let's think about this. What type of model was it in the very first example we did? What type of function? The very, very first one. Linear, right? Linear, you guys just think about it. Y equals mx plus b. The slope is constant. So do you guys see how this is going up by 1? This is going up by 1, okay? This is going up by 0.2. This is going up by 0.4. You guys see that? This is not generally constant, but a linear model is actually the best model to use. Does that make sense? So it's not going to be exact, but it's going to be really close. Okay? Because think about it, like, do you guys grow proportionally over time, or do you guys just get a growth spurt? Like, does that make sense? Like, it's not perfect. So the difference between an actual value and the value predicted is called a residual. So we're going to revisit this again later on. But to calculate a residual value is equal to the actual value minus the predicted value. So in this table, these are your actual values. These are real baby numbers from a hospital. The model that we came up with is the predicted value. Okay? So the residual, another way you guys could write it is y minus this notation right here. Do you guys see like the little, looks like a little caret? In mathematics, this has a funny name. You guys ready? It's called y hat because it looks like it has a little hat. All right, so using the model from example 1, what is the residual of the baby that is 5 weeks old? So we're looking at 5 weeks old. The baby was 4.4 kilograms. Okay. So do you guys remember, you guys have it written down, right? From our first example, so we're all on the same page. This is the same exact table we did at the very beginning of class. So when we calculated the regression, y was equal to what? Can you guys tell me what the equation was when we found the regression? 3 point what? That's it? Okay. So this is our equation. This gives us the predicted weight. Okay. So this estimates what the weight would be. This is the actual data from a baby. Does that make sense, guys? So what it's asking is to calculate the residual. The residual is actual minus predicted. So according to the table at 5 weeks old, what was the weight of the baby? 4.4. Hey, can I sign this for you real quick? Okay. So it was 4.4. The predicted, to get the predicted, what that means is plug in 5 into the equation, because the predicted value is going to be modeled by what we got from our regression model. Okay, so if I plug in 5 into the function, you would get 4.47. So to calculate the residual, all you do is it's actual minus predicted. The actual weight of the baby at 5 weeks old was 4.4. The predicted model says that the baby should weigh 4.47. Okay, so if I subtract those, I'm going to get negative 0.07. Okay. So interpretation. Is our model pretty accurate, you guys say? It's pretty accurate. However, which was bigger, the actual value or the predicted value? Predicted value. So does it make sense that the predicted value shows that the baby weighs more than it actually did? Okay, so what you would say then is our model is an overestimate of the true weight of the baby. Now, if this was positive, that means that our model is an underestimate because that means that the actual value is more. Okay.